So hello guys, okay, very warm good morning to all of you. So in today's class, we'll try to understand, okay, how does CFD work, okay? So the working of the CFD is that we will take one aerofoil, that is my name is 4412, okay? You can select n number of aerofoil series, and then we'll try to import the coordinates of the aerofoil to the workbench, and then first we will try to design the model. After designing the model, we will apply the boundary conditions, okay? And then we'll try to simulate the model, okay? After simulation, we will try to see whether that the value what we are getting from simulation, okay, is almost equivalent to experimental setup or not. That we'll try to verify, okay? Because we cannot do like we cannot solve it like closing our eyes and just solving it, okay? So we should go with some good process. So what we will do, as you can see in the side, okay, you can see here one Fluent is mentioned here in the toolbox, okay? Simply drag it and keep it here. Everyone please pull this part, Fluent, okay? Click on the Fluent part. See here, Fluent is there. Fluent, okay? Yeah, and pull it up. Okay, I will show you again once. See, click this Fluent and it is showing me the green color part, okay? So when I'm keeping it here, it will create a standalone system, okay? So you can see there are set of parameters that we have to feed here. The first one is the geometry, okay? That is, and one question mark is here. Question mark shows me that we have to make a geometry or we have to import a geometry here, okay? So it requires a geometry. Second one is the meshing, okay? So as we know that CFD works on FEM, okay, or FVM, finite volume method. So we have to go with the meshing part also. So we have to do the meshing. Third one, setup. In the third one, we have to give all the boundary conditions, okay? And then after simulation, we'll go for the result, okay? So as I've shared you the NACA series, okay, 4412, the text file. So first today I will teach you how we can import, or first of all, I will teach you how we can make that model, okay? So it can be anyone. So if I open the Google, just wait a minute. Okay, and if I'm typing here, okay, NACA airfoil tools. So you can see here one option is there, airfoil tools, okay, NACA airfoil, okay. Simply click on that part, and you can see by default is showing me the airfoil of 2412 number, okay. So there are n type of NACA airfoil series. So it is showing me for the 2412. But in today's experiment, we will try to visualize about 4412. Okay. So simply I'm clicking here on the top portion and I'm typing here 4412. Okay. I'm typing here 4412. Okay. So in the top corner, you can see search button. Okay. And I'm choosing here 4412. Why I'm choosing 4412? Because it is not symmetrical. Okay. So after if you're searching it, you can see the first one, NACA 4412. Click on this part, and you can see your airfoil is showing here in red color. Okay. So if I pull it more down, you can see this is my data file. Okay. These are nothing but my 2D coordinates. Okay. These are nothing but my 2D coordinates. And these are various CL, CD. These all are the graphs. Okay. So now I will send it to plotter. Okay. Send it to airfoil plotter. Click it on. And you can see here, there are various options which you can change. Okay. Now, as I am designing it for like 1 meter chord length. Okay. So here I will vary the distance to 1000 mm. Okay. Here I will change the dimension to 1000 mm. So my chord length is how much? 1 meter. Okay. Now this my chord length is 1 meter. Again, okay, fine. Again, simply plot it. Just wait a minute. Just wait a minute. Wait. It's not coming. Yeah, just wait a minute. I'm giving the points. Okay. So now, as you can see from here, so this was my, as you can see from here, is my NACA 4412 airfoil. Okay. So you can see here number of points is how much? 81. Okay, number of points here is 81. Okay. Or if you're having difficulty, you can simply search here NACA 4412. Okay. And you can go for here generator, airfoil generator. Okay. You can go for airfoil generator. Just type NACA 4412. Okay. And then just go for airfoil generator. Okay. Now I'm clicking on airfoil generator. So you can see my maximum point is given here how much? 81. Okay. So just we are having this 2D. These are nothing but my 2D coordinates. Okay. So but as I want to draw a smooth line, smooth curve in the figure. Okay. So I will make it to 200. I will make it to 200. Okay. And after making it to 200, I will simply plot it again. Okay. I will plot it. So after plotting it, again, we will go with the same process. Okay. We'll go to the airfoil plotter. Okay. And we'll try to change the chord length. Okay. This is my 1000 only. Okay. So when this part is done, as we are having my chord length is 1000, now we'll try to import all these coordinates. Okay. As which format? .csv file format. Okay. So when I'm clicking on this file, CSV file coordinates, so you can see it is getting saved here. Okay. You cannot see it. Okay. Because that I think your office is not there. Okay. Your office is not there. No, Notepad. Don't open with Notepad. Okay. You have to open with Office. So I will just show you how it looks. So when I'm opening it, so you can see it is looking like somewhat like this way. Okay. It is looking like somewhat like this way. And I have given you one text file. Okay. Everyone please open the text file. So you can see the text file which I have sent you, okay, consists of how many columns? 1, 2, 3, 4, 5 column. Okay. So the first one is your group, first column. Second one is a point. Third one is your X chord. Okay. The fourth one is your Y chord, and the last one is your Z chord. Okay. So if you try to again visualize the file which we have saved, okay, we are just having X and Y coordinates. Okay. So what we will do, we will try to again make one new file. Okay. In which format? In this format. In this format. Okay. So the same thing like this group point X code Y code. Okay. The same thing I have captured here. Okay. So this, as you can see, the first one was group. Okay. The next was my point. Okay. Next one was my X code. Okay. Similarly, Y code, Z code. Okay. And then what I will do, I will try to import all these points. You can see X and Y points are there. Okay. Up till where? Before this. Before this camber line. I will try to import all these points. Okay. So I will simply control C and control V here and I will paste it here. Remaining all three will become as 0, 0, 0. Okay. And this point 1, 2, 3, 4 will go on. And this will become a 1, 1, 1. Okay. And then I will try to save this with which format? TXT file. Okay. We have to save in text file. Okay. So after saving it, it will somewhat look like this type. Okay. So after saving it, it will look like this, somewhat this kind of thing. Okay. Now these are my coordinates. As you can see, for the Z, it is zeros. Okay. And for the X and Y coordinates, we are getting the points. Now we'll try to import all these points in ANSYS. And first we'll try to make a model of it. Okay. So let's go to Workbench. Okay. So now as you can see, this question mark represent that we have to do the sum, we have to do some, perform some work here. Okay. So simply right click here on geometry. And you can go to new design modular geometry, the second option. You can even go with a space clamp. Okay. This is a newer one, but better go with new design modular geometry. Okay. Yeah, everyone please go with me. Okay. So just on this part, right click and open with new design modeler. Everyone has opened? Huh? Okay, once I will show you again. Okay. So you can see this question mark is there, no? Okay. Just right click on it and just you go for new design modular geometry. Click on new design modular geometry. If you are having the Aerofoil like a step file or AGS file CAD model, you can simply go for the third option. That is my import geometry. Okay. So as we are creating a new airfoil here, so okay. So we are going for new design modular geometry. Okay. So when I'm clicking it, so on a top corner, okay, you can see the ribbons are there like file, create, concept, okay, tools, this whole thing. So we'll go over the first one. There's my concept. Click on the concept. Okay. And you can see various options are available here like lines from point, lines from sketches, 3D curve. Okay. So we'll go for the option of 3D curve. Click on 3D curve. Okay. So as soon as I'm clicking on the 3D curve, I'm getting one view here. Okay. Pop-up window has came out and it is asking me in yellow color, coordinate file not selected. That is, it is asking me the data. Okay. So as I've shared the text file of the airfoil NACA 4412, simply just click on here. Okay. Click it. And where have you saved that file? Check it. Where have you downloaded the file? For my, it is in downloads. Check it. Where you save that file. It will come like this way. NACA 4412 text file. Are you getting it? Go to downloads. Okay. Got it? Everyone got this file? NACA 4412? We didn't got. So after this, what I will do, I will simply select this file, NACA 441.2, okay, 4412 points, and simply open it. Okay. So he's asking me a confirmation. Yeah, confirm. Why cannot be found? This opening. Okay. So see, after getting it, okay, you can see one line has came. Okay. So just click on curve here. Okay. Bring a mouse pointer here on this curve and simply generate. Bring the mouse pointer on the curve on this tree line. Okay. This tree outline and right click and generate. Okay. Right click and generate. Either you can go with that option or simply you can see in the corner also you're having this generate option. Either you can go with that one or that one, your wish. Okay. So I got my this. You can see my airfoil is here. Okay. Click on XY plane. Okay. Okay. So when I'm clicking on the Z axis in the orientation, I will get this airfoil. Everyone got it? Click on the Z. Now we'll try to create a surface from this edge. Okay. So this is my file. Now we'll try to create a surface from the edge. Again, so go to this ribbon. There's my concept. Okay. Click on this concept option at the top. Okay. Concept on the top. Okay. And now you can go from here, surface from the edges. This option. Click on this. Okay. And it is asking me blue color. Okay, what give me the edges. Okay, it is asking me the edges. So click on this part on the airfoil and simply apply. Leave it, no issue. Okay. And then simply what I will do, I will simply generate it. Generate. Got it? So you might have got your file. Okay. Now my second thing is that I have to make a domain. So you can see this is my file is there, Aerofoil. So I have to make a domain. Okay. So if you try to visualize, again, I'm stopping it, this one. Okay. So you can see here, if I'm showing this picture, okay. So it is showing that one airfoil is in here in the center, okay. And this one domain they have made. This is one domain, okay. So this domain you can see it's looking like a C kind of domain. It's a C, okay. and this is my fluid domain. So what I will do, similarly, I will make this kind of domain outside the airfoil, and then I will simply subtract that airfoil from this fluid domain. Okay, we will just try to simulate this fluid domain after the subtraction of that particular airfoil. Okay, so first my main motto is that I have to make this domain, fluid domain, outside the airfoil. Okay. Okay, so we are going for the C kind of mesh. Okay, so simply first zoom it out, just rotate your scroll your mouse and zoom it out somewhat small. Okay, okay, now just click on this XY plane, click on XY plane and go for this new sketch. This blue one, so you can see they're mentioning here new sketch, this blue color, new sketch on the top. Okay, above the parameters of, I think here. Okay, this part, can you see it, everyone? XY plane is there, no? XY plane in the top, you can see XY plane mirror is there. Okay, so just simply click on that one. Okay, so you can get, you can see here one sketch one is formed here. Okay, now we have to make the domain in this sketch. Okay, now go to this modeling, sketching, line. Okay, sketching, go to line. Okay, and then I will draw one line here, like this way. Okay, from this corner you can draw it, not random, like you can see from this center line, you can see the axis is there passing from the here. Okay, so from here at this point, I'm drawing it in the top, randomly length. I will give it afterward, dimensions. See, this part is there, no, it was here. Okay, so from here, I have taken this point up till here, one line. Okay, again, from here to here, I will draw one box here, one line here. Again, from here to here, one more line. Similarly, from here to here, one more line I will make it. And then from here to here, I will simply join it. Just we are making one box, that's it. Okay. Okay. So as I told you, I have made this box, but it should be symmetrical. Okay, it should be in this foil should be in the center. But as I have done without giving any dimension, so I will try to do, I will make these two lines symmetrical about this axis. Okay, so what I will do, I will go for this constraint. You can see here, constraints are there. Click on the constraint. Yeah, the symmetry option is there. Click on the symmetry option. Okay, and you can see in the line, it is asking select the line, okay, for axis of symmetric constant. You can see in the bottom line they are mentioning select line for axis of symmetry constant. Can you see it? So see, go to constraint, don't go to symmetry. Okay, so now what we'll do, we'll try to make a like C kind of structure here. Okay, we'll try to make a C kind of structure here. So simply go to draw. Okay, you can see a 3-point arc here, arc by 3 points. Click on that part. So click here, 1 and here. Okay, and then at this center. So you'll get a 3-point arc. Again, I will show it. Okay, wait. No, like this way. Okay, wait. See, you're asking me how to draw. So we will simply go to sketching. Okay, so draw. Okay, in draw option, if you see here, they mentioned arc by 3 points. Arc by 3 points. So click on that part. Arc by 3 points. Select this first point. Okay, select this first point here. Select this second point down and select the center one. Okay, so you can see this kind of C has been made. Okay, everyone got this figure? Now what I will do, you can see this extra line is here. Okay, so this line I will try to trim it. This extra line is here. So that is not required in the domain, fluid domain. Okay, so I will remove this extra line. So simply go to modify. Okay, in the left corner, and you can see this trim option is here. So simply trim it. Okay, everyone got it? So now you can see now we know my domain should look like this kind of structure. But if you go for the experimental setup, if I again want to show you, you can see what I mentioned here, adiabatic solid wall on airfoil, okay, not visible at this scale. That means it is very much small here. Okay, so what we consider, we will always take like 10 times of the length of the chord. Okay, simply 10 times here, 10 times on the up also. So now we have to make our domain big, large. Okay, so the same thing we are doing now. We'll try to now make it large. Okay. Okay. So now simply we'll go to dimensions. Okay. Click on dimensions. You can see in the corner. Okay. Dimensions was there. Click it. Okay. And click on this one. This one. Okay. Okay. So you can see this V1 is coming here. V1. Okay. So V1, now I have to change the value. Okay. So even you can see the values mentioning here. For myself, it is coming 2267 millimeter. Okay. So it will vary for you all. Okay. So as I said, I want the 10 times. So what was my chord length? It was my 1000. Okay. So 10,000. So 10,000 will become my 10,000 millimeter. Okay. No need of giving mm because units we have selected before only. Okay. Just type 10,000. Everyone until here? 10,000. Okay. So now you can see from here as my domain. So when I'm like zooming it out, you can see this length is sufficient. Okay. This top portion from here to here, it is sufficient gap is there. So if I'm making the air to flow from this side, the wall, these are my walls, will not affect the aerofoil. Okay. So my gap is here enough. Okay. But my length is not enough to find the flow. So again, what I said, it should be 10 times of the length. So again, I will try to give it some distance. Okay. So what I will do, again, dimensioning, general. Now I will give this distance from here So now I will try to give this distance from this point. You can see one point is here in the starting at the nose. Okay. Okay. Now everyone has done till now, till here. Okay. So now we'll try to create again the sketch. Okay. Now we'll try to create a surface from this sketch again. Okay. So this domain I have to make it again. Okay. So again we'll go to concept here. Concept. Okay. Gonna top concept, then create surface. Okay. From the sketch. Why? Because we have made the sketch. So create surface from the sketches. Okay. Click on that part. So again, they're asking me the base object. He want the surface. Okay. So click on this sketch part on the left. Okay. Click on the sketch on the left. And then, so you can see when I'm clicking on the sketch part on the left, it is selecting all the sketch which I have done, which I have drawn. Okay. So click here, sketch one here, and then simply apply. Okay. And then simply generate. Okay. So when I'm trying to zoom it out, definitely zoom in, you can see I'm getting here two surfaces. One is my airfoil and the other one is my fluid domain. Okay. Done. Completed. Okay. Now, as I said we will try to simulate just only the fluid domain. So what we will do, we will try to remove this airfoil figure from this fluid domain. Okay. So you might be knowing about the word Boolean operation. Huh? So the same thing we will do here. Okay. So again, we'll go to this ribbon. Okay. And if you go here on the create part, create, you can get this Boolean operation. Click on the Boolean operation. And you can see in the details view, you can get this operation unite. Okay. But I don't want to unite it. I want to subtract this airfoil from this fluid domain. So what I will do, click on subtract. So when I'm clicking again, I'm getting these two options. It is asking me the target body is not selected. And even it's asking me the tool body is not selected. So target bodies means, that means from what we want to subtract. Okay, so total body. So click on this part first. And it's asking me to apply. So before that, I have to select this part, surface. So click on this auto domain. So it becomes somewhat more greener. Okay. And then simply apply. Everyone got this part? Now tool body is my airfoil. Okay. So again, simply click on airfoil. But you cannot see it. Okay. You're not able to see it. Okay. So I am not getting that part. Okay. There will be one plane here. Okay. So what we will do? We'll go down. Okay. In this tree outline, we'll go down. And if I'm placing this plus part, okay, I can get this bodies, line body, surface body. Okay. I can get this body. Okay. So click on the surface body. Okay. And then apply. Okay. We'll check it. And then generate. And then generate. Have you got? Should I do it again? Hmm? Okay, now clear. Now I will try to break this domain into small fragments. Okay, why I'm doing this? Because I have to get a very good mesh. Okay, if your mesh is not good, again, what will happen? Your result will get diverge. It will not converge. Okay, So get a better mesh, what I will do, I will break this part into 6 or 8 parts. This into 6 or 8 parts. Okay. So for dividing that, what I will do, again go to XY plane. Okay. I'm selecting your XY plane. Okay. Again go to new sketch. Okay. Click it. I will give, you'll get the sketch 2 here. Okay. Now again we'll try to make a like a fragment here. Okay. We'll try to make a fragment here. Okay. So in sketch, simply go to sketching, line. Okay. So when I'm trying to zoom in. Okay. So from here, I will just simply draw one line, straight line. Okay. Similarly, again from here, I will draw one line in the downward direction. The point which you selected before, now that you see one dot is mentioning here. One dot is there. From that dot only, I am pulling up this line up. Okay. Pull it up. Delete it. Otherwise, simply okay, leave it. From anywhere from this line, okay, draw one straight line in the up, straight in the downward direction. Okay, draw it. Okay. Now again, we have to draw a line anywhere here. Okay, at this trailing edge. Okay. So again, for here, you draw one straight line up. Last. Again, this one down. Okay. So first you draw like this only line. Okay. But now we don't know whether this line is lying on this diamond or not. We don't know whether this line is lying at the edge or not, at the top corner or not. We don't know, trailing edge. Okay. So what I will do, I will take the dimensions. Okay. I will click at this point. I will click at this point. Okay. And change to how much? 1000. Why? Because we know my chord length was how much? 1000. So now this line will come exactly at that trailing edge. Again, I'm telling you how I did. I want this line to be at the last edge. Okay. What was my total length? 1000. 1000 chord length. Okay. So my chord length was 1000. So what I will do? Where is the H3? See, so to get this time, what I will do? I will go to simply dimensions. Okay. General only. Click in this vertical line at this. You can see it will become red. Okay. Then I want this line to be on the trailing edge. Okay. So I will click on this one and then I will pull this part up. Okay. Again, I'm showing you this part. Have you got this part? Red one? Red one, everyone got red one part? This red one getting everyone? Red one? See, bring this mouse pointer here on this part, on this one, y-axis. First click on this dimension. Okay. After clicking on dimensions, bring this pointer here on this y-axis. You come, you first come, hero, come. First see how you coming. Come fast. See, I went to dimensions. Okay. General. I want this distance this line should come till here, this edge. Okay. I know my this part is fixed. So when I'm bringing it here, it become red color vertically. Click it here. It become yellow. I want this line to be come up till this trailing edge. I know my chord length is how much? 1000. So click here and then pull it up. Okay. So I'm getting a L7. So make it 1000. As I've done it before, so it's coming exactly 1000. Okay. Okay, so now after then, see, after doing this part, so you can see now I got my one line, second line, first line this one, second line this one, third, fourth. Okay. Now again I will try to split into half, this side also and that side also. Okay. So what I will do, I will simply go to draw line. Okay. And then I will try to draw it in this direction, horizontal. Okay. Similarly, here I will try to draw in this side direction. From this trailing edge in this direction, from the starting point in that direction. Got it? So again, now you will have one first, second, third, fourth, fifth, sixth line total. Done. After doing this, now we'll try to extend this line up till the figure. Up till here, we'll try to extend the lines. Okay. So what I will do, simply go to modify. You can see extend line is there, extend part. Okay. Click on that extend and click on these lines. Click it. You can see it is getting extended. Click it. It will get extended. Over, completed. Okay, now we'll go for one more command. That is my projection command. Okay, so why I have done these two lines, all these 6 lines? Why? Because I want to break this domain into small fragments so that we can get a good quality of mesh. You can even go for default measure, but it will not provide you the good quality. Okay, so to capture all the boundary layers, I'm going for this kind of partition. Okay. Okay, so go. Okay, so now we'll go to this ribbon, go to this tools. Okay, in the ribbon part, you go to this tools. Okay, when I'm going to this tools part, okay, we can go to this projection. Click on the projection. Okay, and you can see in this position, it is asking me the edges. Okay, select all the edges. It's not coming. Wait. Oh, yeah, it should come. Only should select. Okay. Sorry. Target body, this one, apply. Wait a minute. Edge on face. Selecting. Not this what. Not selecting.